This conference will now be recorded.
Okay. Hi everyone, good morning, good evening. And so basically, as we have discussed yesterday, we'll just continue from there. We'll have a quick recap of what we, had a discussion yesterday. So, and then, we can move forward with the further topic. So basically, yesterday we started with the identity and access management introduction, and we talked about how many different types of domain we have, like within IAM, which includes access management, identity management, privileged access management, access governance, and data security and analytics. And then we looked into like why did we need IAM, and what is the use of IAM and how IAM works. Then we further looked into what is the identity management. We saw what does identity management mean, and what would be the flow chart in the organization for the IDM and how we can manage it. And then finally, we went through some of the common terms of the identity access management, like provisioning, single sign-on, multi-factor authentication, federation, and then finally we had some a view at a landscape of IAM where we are right now and how our traditional IAM used to be and what is the further scope of identity and access management in future. So today we'll start off with the authentication versus authorization part. Although we did discuss a little bit of what authentication and authorization is yesterday, but we'll look into more now. So I'll just share my screen. Just let me know once it's visible. Yeah, is it visible?
Yeah.
Okay, thank you. So, as the name suggests, authentication. So, authentication, you might be, knowing it like it's basically the act of validating the users whom they claim to be. For example, I claim that I am Vibhor, but there can be many people who can claim that they are Vibhor. Okay, so if everyone is claiming they are Vibhor, that cannot be true, right? So there has to be some unique parameters which defines me, which tells that this is the Vibhor who is he is claiming to be. Okay, so this is like the first step in any security process. So basically, authentication is completed or it can be done via multiple methods. It could be your passwords, which we all use like to log into any application or to any other. It's like the most common authentication factor, right? So if your password is correct, that means like you are the person who you are claiming to be. Then sometimes we get one-time PIN, that is OTPs, like for bank account details and all, or some any transactions we do. We have the concept of OTPs, right? So then we have the concept of authentication, like sorry, biometrics. So biometrics is something like somewhat related to your body part. It could include your touch, fingerprint. It could include your bio, like retina display, or eye scan, something like that. So it's like basically related to something the user possess. And uh, and out of all these factors, we have the first factor and the second factor, that is the multi-factor authentication. So basically what we do as a part of complete authentication process is like we have the first factor, which could be your PIN or passwords or any other thing, and then you'll have the second factor, which could again be somewhat like different. In simple language we say it like password is something and biometrics or other thing is something you possess. So if there is something and you have something which you possess, and both are being validated, then it seems like you are the correct user to be authenticated or to access certain application or software which you are trying to get into. So in certain instances, system requires a successful verification of more than one factor before granting the access. And this MFA requirement is often deployed to increase security beyond what passwords alone can provide. So what does this mean is like passwords can still be compromised. I'm not saying like that's why we have those password recommendations whenever you try to login, or whenever you try to create an account on different platforms, we get to see, right, like 8 words, 8 characters, one uppercase, one lowercase. So what is the need? Why do we have to do that? So the requirement or the need is that we want the passwords to be as complex as possible. Now if someone has kept their password as 123, okay, so now this is something like very very easy to crack, right? Or if people are entering their names, or some like date of birth, or like anything else as their passwords, so then that's not like very difficult, because like everyone is updating their data on social media these days. So like basic details of an individual is something the hacker can easily get, and he can just try out some combinations, permutations and combinations, and he can crack it if it is that easy. So that's why like it's always recommended that you guys come up with some complex passwords, maybe combination of certain characters and special characters, which makes it difficult for hacker to crack. It can still be cracked, it's not that, but for example, like the possibility of cracking is like 1 in 1 million times, then it becomes very very difficult for the hacker, right? Because if it is like 1 in 100, then a hacker can write a script to actually crack your password. But if it is like 1 upon 1 million, so then it will, the script will also take time, right, to actually go through 10 million, 1 million records, and then try out everything and then finally crack it. So if you feel that at that point of time something is happening with your account, you get that time to go ahead and change it, and then that script is running right from the beginning. So that's why complex passwords are always recommended. And the multi-factor is just adding a layer of security on that first factor, which is like your passwords can be a first factor, because now even if the hacker is trying to authenticate, I mean trying to crack your password, but then he has to go through another layer of security, which is the multi-factor. You might be getting a code on your phone, or some like face recognition is there, so that becomes like a very difficult task for the hacker to bring in. Like face recognition is something very difficult for a hacker to uh, replicate someone's face to actually bypass the MFA. So that's why. And also, like I'll just give you guys one example of credit card. So I don't know if you guys have ever noticed it, but what happens over there is like you enter your CVV number, right? And uh, it could be correct, it could be wrong. But what happens is like the moment you enter your CVV and click on submit, you get a OTP for the transaction. Okay, and if that OTP is like if you get a 6 digit or whatever your bank says, you get an OTP to enter. Now if you enter that OTP and click on submit, at that point of time itself, your transaction is declined, saying that your CVV was incorrect. With like from an end user perspective, we might think why that is happening, right? Like if our CVV was not correct, why are we getting the OTP? We shouldn't get the OTP, no? Like we can the transaction should decline at that point of time, only saying that like your CVV is incorrect. It should not give you the OTP to go ahead and enter and click on submit, because after you enter your OTP, that means that the transaction is finally going to happen. But still the transaction declines because at first step your CVV was not correct. So the logic or the reason behind this is like the CVV is 3 digit. Okay, so hacker has to do 100 combinations. Like for 3 digits, he has to make 100 possible combinations. Oh, sorry, 1,000 possible combinations to crack your CVV. Now at that point of time, if the hacker cracks it, so and you don't get the OTP, so then he can bypass it. Because like if your CVV is incorrect at that point of time itself, the hacker will go ahead and try the second combination. But now what is happening is he'll get that 3 digit combination, I mean the CVV. At that point of time, OTP will be generated, which is another 6 digit. So that means 3 plus 6 equal to 9 digits in total. Okay, and now the hacker has to try 10 raised 10 raised to power 9 combinations in order to crack your OTP. I mean, in order to crack your combination. because like your combination is consisting of your CVV plus your OTP. If it is just CVV, because that is just 3 digit, it's very easy for the hacker to crack it. And hence we get it like our combination is CVV plus OTP, and if that is correct, then only you go ahead and do the transaction. But for the hacker's point of view, that becomes very difficult to crack, because that is like 10 times, like 9 times into 10, which is like a very very big number of combinations which the hacker needs to try. So that's why, like on authentication part, it's always recommended to have multiple factors of authentication. And that's what, like authentication is all about, basically validating the user who he claims to be. And next we'll move on to the authorization part. So it's basically the process of giving the user permission to access a specific resource or a function. So your resource could be anything, like maybe your application, your hardware, your software, or your network. So if like basically give, like now the user has validated or proved that he is the correct user to enter into your system, but like still that user should not be having access to everything. Like if you are working in an organization or any other place, so you might not be giving might not have been given all the IT admin rights, right? Like you might be responsible or working with only that particular access for which you are working on the in the organization. We don't even get admin rights on our corporate laptops, right? So that's the reason, like access needs to be defined for everyone. Like we cannot give access to everyone for everything. So that's why it's like most basically selecting what user permissions needs to be given, and that's what authorization means. So giving someone permission to download a particular file on a server, or providing individual users with admin access to an applications are good examples of authorization. So I just mentioned that thing, like maybe admin, or sometimes what happens if it is your corporate laptop, so you are not able to download the files, or you cannot upload the files. That's because that access, or that permission is not granted to you. If you have to probably raise an IT ticket, and IT guys will come in, and they'll help you install certain softwares, or upload or download the files. So accordingly, like it's just an example, but basically authorization is that only, like restricting, or giving selective access to the user as per the requirement. So that's what authorization is all about. I'm like I'm sure that you guys must be having a good idea of what authentication and authorization is, because next we are going to see the single sign-on. And single sign-on is basically achieving these protocols. Single sign-on is us having different protocols, and those protocols helps us to achieve the authentication and the authorization part. So we'll just deep dive into that next. And before we deep dive, like any doubts till now, I'm happy to take it up. Okay, silence means I'll take it as a no. Just let me know if you guys have any doubts. Okay. So SSO protocols is the next topic, and a very important one. And I would request you guys to please pay more attention from now on, because we are going to talk about SAML and OIDC, the most famous and the standard protocols which we have for the single sign-on. And next, and the other two which we have is like the secure web authentication, that is called SWA, and WS-FID. But 90% of the applications which you are going to integrate in Okta would be SAML and OIDC, or somewhat SWA. WS-FID is something not very much used with Okta, so we are not going to go deep in depth for this protocol. But we are going to have a look for what SAML is and what OIDC is, and then we'll see and we'll take it from there. Okay. And so please now I would request, like if you guys are not following me anywhere, like with regards to what SAML is, just let me know, because this is a very important topic to cover. And hence I would request you that please pay for more attention from now on. So basically, if we talk about single sign-on, so what happens is, like you have your system. if you're logged into your Okta application, which we are going to, finally have, which we are going to, study in the upcoming sessions. So if you're logged into your Okta session with your username and password and, doing your multi-factor and stuff like that, then there would be Okta, which would be an HTTPS request. Okay, you will be going to your browser, like on your laptops, you will be going to your browser. There would be a link, where your account would be created for Okta. You will be hitting that link, and once the request is gone to that link, you will be redirected to the login page. Now that login page, you will enter your credentials, username and password. If you have the MFA enabled, you will be, like verifying yourself by the second factor, and then you'll be logging into the application if you are the right user. Now, once you're logged in, you might be able to see different applications on your Okta dashboard. There is a dashboard in Okta. I'll show you sometime later, but you will be, or I can show it to you now also. Somewhat like this. Currently, it's like, I don't have anything right now over here, but this is how your dashboard, and it will show you all your apps over here. Okay. We are going to see how you can come to this page. If time permits today, we'll see it today. But yeah, I mean, this is how it is. We'll integrate apps, and then once the apps are integrated, you can see that your apps will be displayed over here. And that's where, like, if you click on the apps, you should be able to do the single sign-on. Now, like what type of single sign-on will depend on what type the integration has taken place, right? So it could be, OIN. OIN is Okta Integration Networks. Okay? So you can think it of as like, the standard connectors. There will be two types of connectors in Okta. One would be standard connectors, and the other would be custom connectors. So standard connectors is something like which is part of OIN, that is Okta Integration Network, and custom connectors would be something we'll be creating on our own. So both of them has nothing to do with the coding and stuff like that. Both of them are pretty much simple to do it. But before we actually implement, we need to understand, like, what are we actually doing it, because if in case like the integration doesn't take place, or if it is not happening properly, so we guys should be comfortable or confident enough to troubleshoot the issue also. And for that to happen, we need to understand what these protocols are and how these protocols work. So yeah. So let's start off with the SAML topic first. So SAML is basically your security assertion markup language. That's the full form of your SAML. And there are certain terminologies on certain terms which we should be knowing it, which we will be using on a regular basis if we are talking or communicating on SAML. So first two most important things on SAML are the service provider and the identity provider. Okay. So now the service provider is the entity providing the service. Okay. Typically it's in the form of an application, like, so what happens is, for example, you are trying to use Zomato. Okay. And from Zomato, you have installed an application Zomato, or any other, maybe or maybe Amazon. And Amazon now it doesn't have, but like initially in the earlier days, we used to have that Google sign in, like continuous sign in with Google. Okay. So Amazon is your service provider, and if you are getting that option sign in with Google, Google becomes your identity provider. Now, why Google is your identity provider? Because over there, Google is asking you, because you are logging in with your Gmail ID or whatever your Hotmail ID, whatever it is, and that ID is stored in that particular platform. Like Google is storing all the Gmail IDs. So Google is authenticating and trying to make sure that you are the right user. Now the thing is, like, why are we having this? Like, why is it that why Amazon and Google are trusting each other? Like, Amazon has nothing to do with Google, right? Like, people who are there on Google, they could be malicious users, they could be right users, but like how Amazon is like totally a different application, right? So why Amazon is trusting Google over here? The reason being because Google and Amazon, they have a trust between each other. There is a trust, like they have the, like Google contains all the information of Amazon, and Amazon contains all the information of Google. So they have a trust between each other. And now if there is a trust between two entities, then they can trust, like then Amazon can trust Google, okay, this is the right user. Okay, so that's what happens. Like if you want to understand in layman's language, a service provider is something which is giving you the services. So eventually, what are you going to do after login? You are going to, like, add certain items in your cart, or like the services will be provided by Amazon, right? Eventually, but who is the identity provider? Who confirmed that you are the right person, or the this identity was correct? That was Google. So that makes Google as your identity provider and Amazon as your service provider. So IDP, and just mark these terms like SP and IDP. Like like everyone speaks in these terms when we talk about SAML. So SP is something an acronym for the service provider, and IDP is the acronym for the identity provider. So IDP is basically the entity providing the identities, including the ability to authenticate a user. That's what we discussed with the Google Amazon example. The IDP typically contains the user profile, which includes additional information about the user, such as first name, last name, job code, phone number, address, and so on. Like these are just certain examples. It could include everything, like everything in the sense like whatever it requires. So I told you, right, that there is a trust between these two identities. That trust is actually containing information, okay, about the user. So like there are certain attributes like the first name, last name, like job code, phone number, maybe location, or any other user attribute which is required to maintain the trust. Okay, so depending on the application, some service provider requires a very simple profile. Yeah, so like every application does not require, okay, you give me these set of attributes. Like every service provider does not ask the identity provider like that you give me these list of attributes of the user. They are fine with username or email, some basically some simple applications. But others may require a richer set of data for the user, like all the job code, department, location, manager, group name, everything. So like that depends on application to application. Like once we'll start integrating, or integrating the applications for single sign-on, we'll start getting to know how it works. But basically this is it. Like there's a service provider, think of it as a box. There's an IDP provider, think of it as a box. And these two are having a trust, and these two are having a trust between each other. There is some exchange of data. How that data is exchanged is something we'll see when we'll be integrating applications in Okta. But yeah, like we have two different boxes and they are communicating with each other. If the identities which are being authenticated are correct, person logs into the person logs into the application. If they are not correct, they don't log into the application. Next, we have the SAML request, which is like the authentication request generated by the service provider. Now, like think of it like this Amazon Google example only, right? So, like first, where are you going to go? You are going to go to the Amazon app, right? Initially, why will you go to Google and say, okay, I will authenticate via Google, and then I'll go to Amazon? Will that work? No, right? It will not work. You have to hit the application first, and then once you're hitting the application, you will be redirected to IDP. You will get like, okay, sign in with Google option over there. So you'll sign in with Google, and then you can just go to the application finally. So that is like that service provider redirecting you to the identity provider is the SAML request. That terminology is the SAML request. And now the SAML response. So if service provider is sending you to the identity provider, that identity provider would be taking some action, right? Like the request has come to the IDP. So now IDP is not going to sit idle, right? That IDP will do something. It will it will authenticate the user, create a document, and in that document it will include, okay, this user was authenticated at this time, and these are the user attributes, these are the values, and so on. And it will send back the request response to the service provider. Okay, and in that particular response which is going back to the service provider, that contains the information. Like this SAML response is the main thing. This is containing everything, like whether the user was authenticated or it was not, at what time the user was authenticated, till what time the user should be logged in with this session, what are the user attributes. So this is like an XML document, uh, that will be, going back to the service provider, and service provider will be reading that document. And once service provider is satisfied, okay, this is the right person to, get into my application, to get into me, so then it allows you to, log in. So this is basically, SAML request and a SAML response. While we are going to integrate the applications in Okta, I'll, show you uh, through like, through different tools, SAML tracer and all. There's a SAML tracer extension in our browser, which actually, allows us to see what a SAML request is, how a SAML response looks like, what is the identity provider, what is the service provider, and so on. Okay. Now, then comes the another two concept in SAML, which is the SP initiated and the IDP initiated. Okay, so now SP initiated, you can think of it like, uh, you go to the application first, and from application you are redirected to the identity provider. Okay, so you logged into Zomato, or, any other food service app, and then from there you are, you are getting into the you are redirected to the Google or any other identity provider, maybe Facebook, Google, and once you're authenticated, you are finally back into your application. IDP initiated is completely opposite. Okay, you go to the identity provider first. For example, like you log into an application. In case of Okta, you could see that. I mean, Okta supports both SP initiated as well as IDP initiated. But in case of an Okta, you can see like over here, you logged into your account. Okay, so you prove that you are the correct person because this is your identity provider. Then you are seeing different applications over here. You might be able to see Zomato, you might be able to see some other applications, whichever are integrated with this particular, for whichever the trust is maintained. I mentioned the word trust, right? For whichever the trust or that federation is there, you can, just come in and will be able to see those applications. Currently, I don't have anything, hence I do not see anything. But I logged into identity provider over here, and then I see different applications over here. So I click one application and it logs me into that application, maybe some Salesforce, or, just like for the time being, you can think of Amazon only. Okay, so Amazon was there, and you clicked into Amazon and you logged into Amazon. Okay, so this becomes your IDP initiated flow. Because why? Because IDP was your first point where you landed, and an SP initiated service provider was the first point where you landed. So from in service provider, you landed on the application first, went on to the IDP, which is going to authenticate the user, and then finally back to the application. That's how the flow is. Like, if I need to describe over here, so it's like SP is your application, and IDP is your maybe, example, you can take it as maybe Google or Okta, or, Facebook, stuff like that. And once, so for SP initiated, if you have a flow, like, so you have to go to the application first, and from there you are going to go to IDP for authentication. Once your authentication is successful or it is not successful, if in case it is not successful, you will get a message saying that you are not a legitimate user, right? I'm sorry. So if in case your authentication is successful, you log into the app. Okay. And if it is IDP initiated, so you go to the IDP first, and from there you get authenticated. And once that authentication is successful, you log into the app. So this is how it is like. And over here, I mean, the authentication happens. So these are the two flows. Now there might be a question that, why do we have to, do this thing, the SP initiated thing, when, this flow looks more fast, because there is, one less step to cover over here. Now the reason is as per the requirement, because, like, you are owning an application, you are the application owner. Why would you need people to, not go hit their application and instead hit the identity provider, and then authenticate and finally go to the application? So that's why, people want that, they should hit their application, because see, there could be many applications, like 100 applications, and you are an application of only one application. So you don't care about other applications, right? You want like my end users or the users for my application, they should start like continue hitting the application, and they should be able to view certain pop-ups or messages over there to how they can sign in, like they can sign in with Okta, and if they can do that, then they should be redirected. So then the point comes, why do we need IDP initiated? So IDP initiated is like, mainly some business to business application. You can think of it like, you are a business owner or the application owner for multiple applications, and you don't need to, you don't want your end users to remember the URLs for every particular application. So you can give them that, liberty that you just go to Okta, you just sign into that application over here like this, and you will get to see all those 5 applications. Don't worry, you don't need to, bookmark or do anything with those URLs. You can directly log into those applications. So that's like, it's like, there's nothing to compare between IDP initiated or SP, like which one is good, which one is bad. They are, implemented as per the end users use case, as per the application team who is owning the application. They want both, they get both. If they want just SAML initiated, I mean SP initiated, they get SP. If they want IDP initiated, they get IDP. But Okta provide, supports both of them. So these are some common, SAML terms. We'll see more into it now. So basically, but yeah, any doubts till now, like, guys, please make sure that, you are getting these things, because these terminologies are going to be used later on. We are just going to see how SAML works, and then later on, when we are, going to work in Okta with the applications and the integrations, at that point of time, these terminologies would become very important. So, like, if in case you are not following me, please, come up and let me know.
So I have a question. In IDP initiated, do we need to put in our credential again in any of the apps?
No, that's what
So it's
single
like,
sign.
okay, yeah, okay, got it. All right.
Yeah.
Mm-hmm.
So once your session is established, and like you are just going to see the application here only when, that application is integrated with some single sign-on
All right.
protocol. Yeah,
Mm-hmm.
SAML, secure web authentication, or OIDC, and then like that SSO will work, and you won't require to enter your credentials.
Okay, thank you.
Yeah, no problem. Okay, then we are going to see some more, terminologies in SAML. This is again, like, this is now, we are getting more into SAML. You might not be, seeing these terminologies on day-to-day basis in Okta, but like I mentioned before, it's very important to know these things, because if someday your application is not working, like the single sign-on is not working, then you should be knowing these terminologies, because that's the way to, troubleshoot it. You should be knowing, okay, this is the flow, this is how it should work. ISP initiated means the request would have come to the application first, then it would have been redirected to this. So is there any issue between, is the request went to the correct page, and stuff like that. So that's how, the troubleshooting skills will increase. And trust me, you are going to face those situations where you are going to, have the issues with the integrations. Like, every integration is not going to be, very smooth. Okay, you integrated it and there was no issue at all, like, never ever. So that's why, it's very important to understand from the root level, like what SAML is and what are all the terminologies associated with it. So next we are going to talk about assertion now. So now I did mention one thing, like, up in SAML request and SAML response. Okay, so I told that, for example, there would be a SAML request over here, which will be, going through the IDP, through the SP provider, like SP sending it to IDP. Okay, and then there was a SAML response, which was like IDP sending to SP. Okay, so now over here, this is like, that assertion thing. This is like that if we have to give it a term, this is like what we call an assertion. So now what happens is, it's the data provided by the identity provider, which, contains one or more statements about the user, like, as I mentioned, when the user was logged in, whether the user was actually authenticated or not. It could, also write, no, this wasn't a legitimate user. I could not authenticate or verify it. So then back to the service provider, this data will go back to the service provider. Service provider will say, I'm not, allowing you to enter into my application because you don't seem to be the right user according to the IDP. Okay, so it's like basically an XML document which is being provided by the identity provider to the service provider, and it contains different statements. Like one is authentication statement. So it is basically, in layman's language, it's basically telling whether the user was authenticated or not. Obviously it is going to contain much more information what I'm saying, but from a high level perspective, that is what it is going to say, that the user was authenticated or the user was not authenticated. Obviously it's not going to write it like, since it's an XML document, so there would be, XML language which in which, it will convey it back to the service provider. But if we need to understand, then it's like, this thing only. It might contain whether the user tried to sign into this application at 5 p.m. a user was not authenticated or something like that, and what is the reason why, maybe password is incorrect, maybe username is incorrect or stuff like that. So basically, but authentication statement will contain this thing. Then there would be attribute statements. So we did mention, right, like over here, that certain applications require, like application is your SP, which is service provider. So they require certain set of attributes to be provided by the IDP, because there is going to be a trust, right? So SP also needs to take data from the IDP. And since they both are trusting, so that's why both are exchanging the data. Although user data is something very confidential, right? You might have heard of that Facebook is selling the data. So is that, what is going to happen? User data should not be sold to anyone, no? Like it can affect the end users. So but over here it's not selling or anything. There is a trust of compliance and security, that no one is going to publish the data or misuse the data. And once that trust is there, they are going to exchange the data, because that is required over here if they have two parties. Okay, so attribute statements is some yeah, so there would be different types of attributes which will be flowing to from the identity provider to the service provider. So it could so if you have any attributes, no, like your username, like I logged in to Okta, and then I'm trying to log into the application. So that application might be requiring my phone number and my email address. So in that assertion, it will go, okay, Vibhor g69@gmail.com is the email address, and my phone number 1234567. Okay, so that's how it will be like. Attribute statements will be containing all the attributes which will be flowing from the identity provider to the service provider. And then the authorization decisions. So authorization decisions is basically like whether to declare that a request to allow the assertion subject to access a specified resource has been granted or denied. So for example, like let's talk about that you have an application, and that application is containing different roles. Like even if you look over here, no, to this particular application, currently think Okta as a service provider, not as an identity provider. Okay, so you logged into the application, you logged into this particular URL, you logged into this particular, you logged into this particular URL. Finally, now there would be different, yeah, I think I logged in. Okay, you logged into yeah. So you logged in over here, and you wanted to log in over here in the admin. Okay, now you are not an admin in Okta. You are just an end user in Okta. You should not be seeing this button over here, but you are still trying to log in over here. So that is something which will be validated. Okay, this user has what level of access? Is he a super admin, group admin, role, like whatever different types of admin we have in the application? Is that a user allowed to access that? Access to the application is granted and the authentication statement. But under the application there are different use cases. Like for example, you take an example of Amazon. Now either you could be that agent who is like that customer service agent. That person is also trying to log into the application. You as an end user is also trying to log into the application. Should that end user, when he is trying to authenticate himself with his like work credentials, which is his like customer service job, will he get the same application? No, right? He'll be logged into the different pages, or he'll be seeing some different screens what the end user is screen. So that's where the roles or the access is defined to the application, like this user should be able to see this thing. And that's what, like, SAML will be carrying in the authorized decision statements that will help service provider know. Suppose there are two screens on the application, screen 1 and screen 2. It will, in layman's language, it will say this user should be redirected to screen 2. And for other user, maybe the statement goes like this user should be redirected to screen 1. Okay, so this makes like that authorization stuff, like based on the role or the permission which the user was granted in the application, the user will be redirected according to that particular screen. So this is what an assertion is. Okay, so if I'll just repeat it again, assertion is that particular XML document or the data which is being sent by the identity provider to the service provider, which is like the IDP who is authenticating the user, service provider to which you are going to leverage the services of, typically an application. Now this will contain three different statements. One would be the authentication statement, then the attribute statement, and the authorization statement. Authentication statement in a layman's language, it will just let the service provider know if the user can log into the application or not. I mean, if the user can use the application or not in any way. Don't think of the rules. If the user cannot log in, he'll be thrown out. Like, he won't be able to get into the application. Attribute statements would suggest what level of data, like what user attributes, or yeah, user attributes are flowing from the IDP to the SP. And authorization is like what level of access the user has in the application, so accordingly what user should be doing it. So these are those three statements which an assertion consists of. Now ACS is assertion consumer service. So this is again an important point now. So now the assertion is, it's being sent from IDP to the SP. Okay, IDP is sending the assertion to the SP over here. Okay, now SP needs to have somewhere, like that assertion needs to be consumed. No, consumed in the sense SP needs to read that assertion, right? So then only SP, that is the application, that then only it will be able to make a decision, right? So service provider needs to read the assertion, and that's where it reads it as, which is known as ACS, that is assertion consumer service URL. So the place, or the point where the service provider, that is the application, it is going to read the assertion sent by the IDP, like you can think of it like it needs to read and understand what is it, like it needs to understand these three things, because it will be coming in an XML format. So they need to understand what is it, and once it's understood by the service provider, then only action will be, or then only the redirection to the correct login page of the application will be done. So this is like basically the service provider's endpoint URL that is responsible for receiving and parsing a SAML assertion. Now when I say service provider's endpoint URL, it's not the app URL. Please don't confuse it with the app URL. Like for example, if you have facebook.com, it is not going to be consumed at facebook.com. Endpoint URL means some mapping would be there with the URL. Like for example, maybe you have, right, like maybe Facebook, like maybe Facebook, over here you might be have some mapping, like maybe SAML, SSO, somewhat like this. So that's what it is like. Okay, so there will be some mapping to the URL. So that is like the endpoint URL, and this is going that yeah, some service provider use a different term for the ACS, which is like some say ACS, some say single sign-on URL, or SSO URL. So yeah, so it's, and in Okta also for the ACS we have a single sign-on URL field. It doesn't say ACS in our Okta. But if if you have worked with, or if you'll be working with some other tools like Ping Federate, over there over there we have ACS term. Okay, so but they both are same, like whatever is the ACS URL, that is the single sign-on URL, that needs to be entered, and then only that needs to be configured in your integration or the application which you're trying to integrate. So once that assertion is consumed by the service provider, accordingly the decision will be made by the service provider. Okay. Now we have been using this term attribute a lot of times. So what is it? So it's basically a set of data about a user. Okay, so like the username, email, phone number, location, geographical location, somewhat like everything based on the user. Like it's basically the set of data for a user. So like I am sure you might be already knowing it, but if in case like if it was confusing, like attribute, so this is what an attribute is. Audience restriction now. Audience restriction is a value within the SAML assertion itself. Okay, so which will be specifying who the assertion is intended for. Okay, and the audience will be the service provider, and it is typically a URL, but technically be formatted as any string of data. If this value is not provided by SP, then try using the ACS. Okay, so now what does this mean is like this assertion will be going from the IDP to the SP, right? So in that IDP, in that assertion, there would be many things. Now one of the things that will be going back would be your audience restriction. Okay, so audience restriction is, and audience restriction is that audience is your service provider. So while the IDP is sending it back, because IDP is not just authenticating with that particular, over here there are going to be multiple applications, maybe application 1, application 2, application 3, and so on and so forth. So IDP has to understand, no, IDP has to point back to that unique application for which it is currently authenticating. You can think of it like there are 5 applications. App 1, we have people A and B. Okay, we have app 2, and so for this also you have people A and B, A, B, and C. Okay, so now if your application is being authenticated, so see, A and B have access to application 1 and ABC have access to application 2. But what is the common thing? A and B have application access to both the applications. And what is the common thing between them? IDP is same. IDP is same for both of them because they both are integrated with the same IDP, which is your Okta over here, let's assume. So now Okta should be knowing it, no, whether like it's authenticating a user 1, which is people A. Now when it is authenticating person A, so at that point of time it should know now like for which application it is doing it. Either it's for app 1 or app 2. It should not that person was trying to log into app 2 and the IDP has authenticated the user and send it back to app 1. That's not true, right? So that's what like an audience restriction is like, because IDP is having a lot of audience, and audience is your service provider. So IDP needs to understand what would be that unique thing about this application to which it should send you back. Okay, so that's what the audience restriction is. Default real estate is the URL that the users will be redirected to after a successful authentication through SAML. So it's basically a URL that the users will be directed to after the authentication is successful. So basically the endpoint URL of the application. Endpoint is the URL that are used when SP and the IDP communicate to one another. So yeah, so that's what like over here we mentioned that the endpoint, service providers endpoint, and stuff like. So endpoint URLs are like those URLs to which these two parties are communicating with each other. So like basically like we'll have certain unique URLs to by which these two parties will be communicating with each other, and that's what the endpoint is. Then we have the entity ID. It's again a global unique name for an IDP or a SP. So see, what happens is like you have app 1 and app 2, right? So if you are having app 1, this should have, you have app 1 and app 2, two same applications. Okay, now app 1 is different, like, and this is different. Like for example, think of it like Salesforce. You have got 2 instances of Salesforce integrated. Now you'll say, why do we need 2? We can have 1, no? But there are different tenants, no? Like there is a team which is working with tenant 1 of Salesforce. There is a team which is working with tenant 2 of Salesforce. So they cannot work on the same Salesforce, no. So that's why we have integrated both of them so that both can leave the single sign-on. Now both applications are having same name, everything is same. So how will Okta come to know that which application it is authenticating, and how to which it should redirect to? So that is being done by the IDP, like through an entity ID. So every application which is created, it has a unique ID associated with it. Okay, so that entity ID is being sent from that entity ID is something which globally describes that, see, I am this person, I mean not person, but like I am this application and I have my unique ID. So basically, you can think of it as a unique ID for both IDP and the service provider. Like be it an IDP that will never have an ID which will be different, or be it a service provider that will also have a unique ID. So basically these IDs helps us to I'll show you all these terminologies, like in the metadata file. Metadata is like data above data. So but like don't confuse with the metadata terms right now. I'll show you that XML document how it looks, and when the trust is maintained. So we will see all these terminologies over there. So entity IDs is like, over whatever we have discussed till now, ACS and entity are the two most important things we need to have while integrating a SAML application within Okta. Like you might be interested in certain attributes and stuff like that, but these are like the basic things we need. Without ACS and the entity ID, we cannot integrate the application. So next is IDP, that is identity provider. We have already discussed this thing. Next comes now the concept of metadata. So I mentioned the term about trust, right? So it is basically a set of information which is being supplied by the IDP to this SP and vice versa in an XML format. Now what happens is, like suppose you have Okta and you were trying to integrate Amazon or Facebook with Okta. Okay, so now like they don't know each other right now, so why should they allow the users to be authenticated via Okta? Amazon people don't know Okta, they are completely different organization. Okta is a different organization, so why should Amazon come back to Okta saying that, okay, you allow the users to authenticate, you authenticate the users, and I will give the services? Why? What is the need for that? So first of all, the need for that is for the single sign-on services. Like if people are using, like I'm talking Okta right now because we are using Okta, but generally it's Google on the internet. Like because people are generally logged in with their Gmail IDs, right? So that's why like you just need to have one session created with your Gmail ID and you can use anything. You don't need to log into the application again and again, right? So that's why that's the main use actually. But let's think of it like for Okta and Amazon. So uh, so in order to have a trust between these two identities, and even Okta would say back to Amazon saying, why should I do it for you, right? So, and how, why should I trust you that you are the right that you are using the right application, or legitimate application? So that's where they there is a handshake between the two parties. They'll say, okay, because we have a use case, we have a purpose to solve, so let's shake our hands, and we'll make sure that nothing is compromised or breached. So at that point of time metadata comes into existence. So what will happen is that Amazon will send its metadata to the to the identity provider, which is Okta, and Okta will say, okay, and I will provide my metadata to you. So that's where the exchange is happening. Now, what is metadata? Metadata is actually the stuff which is like, it's a set of information provided by the IDP and SP in order to maintain the trust, and it will typically include all these terminology which we discussed above. So like the ACS URL, audience restriction, name ID format, the certificate, and everything is in an encrypted format. So at this point of time, SP metadata files cannot be imported in Okta, and IDP supplied metadata will provide this. So same, like it's basically the same set of data which both of these parties are giving to each other. They are saying that this is my entity ID, these are my ACS URL, this is my certificate. Certificate is the most important thing to maintain a trust, so to generate or create a trust between two entities. So they will supply all of this data. Once both the datas are configured on both the side, like the metadatas, that's where the trust happens, and that's where this exchange of data happens. And now they are best of the buddies. They will say, okay, we trust each other. You IDP, you authenticate the user, and SP, you leverage you give the services. So that's how SAML works. Like, although we are going to see in the how it will be working in a flow, but that is basically the background. Like, metadata will be having all of these terminologies whatever we have discussed till now, like the assertion, ACS, audience destruction, default real estate, entity ID, endpoint URLs, and stuff like that. So next we have a name ID. It is again also an attribute, sending for example, you have a username. Like, while I was trying to authenticate here to Okta, I got an option. So this is my username, So you have a username, but you don't want your email address to be your username. Supposedly, like, although this is a very vague example, supposedly you just wanted your phone number to be as your username. Okay, you want like uh, maybe you want to log into an application using a phone, or you want to authenticate to IDP using your phone number, not your email, or your not your name. So at that point of time, your name ID format, that attribute value will be something like your phone number attribute value, which will be going to the service provider. So that is the only thing. Like, in IDP, you need to make sure that you are authenticating. Like, by default there would be some value. Okay, by default generally it's email address in Okta. But if in case you want to use a custom attribute, maybe your last name as to authenticate, so at that point of time your name ID format would be that particular attribute, which you will consider it as your username. So that's what the name ID is. Then we have service provider. Again, we have already discussed what service provider is, and the same single sign-on URL is exactly the same what ACS URL is. So now we have discussed all the terminologies, what an assertion is, ACS URL is, attributes are, audience restriction, entity IDs, and finally metadata. So I'll pause here for a moment. If you guys have any doubts with regards to any of the terminologies, please come up. Okay, okay, so then I'll consider it as a no. But if in case you guys have any doubts, any questions, just let me know. Okay. Next, like this will be our last slide for the day. So basically, we are just whatever we discussed till now, we just want to make sure that we understood it correctly, and that's why we have this flow over here. Okay. So you can think of it like yourself as an end user, and you are using a browser, so that becomes your agent. Okay, so this is an end user browser. Suppose this is your Chrome browser. Okay, and you are using it. Now user sends a request to the service provider. You want to log in via, you want to leverage maybe Amazon. So over here you hit the Amazon URL. End user is going to the service provider from the browser. Okay, now service provider, and because end user went to the application first, this becomes our SP initiated flow. We discussed before, right? Like, there are two types of flow. One is SP initiated flow and the other is IDP initiated flow. Because the end user went to the service provider, so this becomes our SP initiated flow. Now service provider redirects the SAML request back to the browser. We discussed two terminologies, SAML request and SAML response. So since it went to the SAML service provider, so service provider has to do something, no? Like, it will be sending a SAML request if in case that application is SAML integrated. So that service provider, that is the application, will be sending a SAML request back to the browser, and browser relays the SAML request back to the IDP. Okay, so like, request will come from service provider to the browser, and browser will redirect it to the identity provider. Now over here, it will try to identify and authenticate a user. Like, it will say enter your username, credentials will be entered here for the first time now. on the IDP layer. Okay, so once you enter the credentials, it will either authenticate you, or it will either say you are not the right person. But what will happen is that IDP will generate a SAML assertion and will send it back to the browser. Now that SAML assertion is something like a SAML response, which we discussed before. So SP sent a SAML request to the browser, browser redirected to the identity provider, and identity provider did its work. And once it came to know whether it's a legitimate user or not a legitimate user, it will create a SAML assertion and will send it back to the browser. Now browser sends it back to the service provider, and this will go to the ACS URL. Now that ACS stuff, no, assertion consumer service. So from browser, this will be going to the service provider. Now if a user is authenticated successfully, so then because the assertion is consumed at the service provider, SP has read that assertion and it has understood what IDP did over here and what IDP is trying to communicate. So if a user was authenticated, then SP sends the security context to the browser. And like if the user is authenticated, no, so over here service provider goes back to the end user browser. Now it tries to request a resource from the service provider, like about the user. It tries to understand, and then like whatever, for example, over here, like over it try like it at this point of time, no, from 7 yeah, from 7 to over here, when it went from point number 7, the user was authenticated and it was logged into the application. Now if I'm trying to if I had the access, and if I'm trying to leverage the stuff like this, somewhat, like think of it as an application. So I try to request a resource from the browser, and this time service provider will not ask any questions. Like now IDP has gone, it will just allow you to directly work or leverage services of the application. So till point number 7, IDP and SP both were into the picture. Now since everything is done, single sign-on is done, authentication is successful, and so at that point of time, now you can start leveraging the resources of an application, whatever are the services that the application provides. So that's how we have the SAML. That's what the SAML is all about. It's basically two types of flows, IDP or the SP. So if what we discussed was the SP initiated, but had it been the IDP initiated, from here the user would have directly gone to IDP, and then the process continues from 4 to 7, and that's it. Like, so this contains all both the flows, like ISP initiated and the IDP initiated, with all the terminologies which we discussed before. So any doubt or anything which is not clear, please let me know. Okay, then I think I'm good for the day, and we're done for the day. I would request you guys to please go ahead and read more about SAML. Although most of the things have been covered over here about the SAML topics, but if in case you might have not followed something in the middle, just go ahead and read all these terminologies and the stuff on SAML which we have, like the flow. If in case anything is not clear, no, tomorrow first thing in the morning, tomorrow first thing we start the session, we'll be doing this thing only. Like we'll revise what SAML is, like in 5 to 10 minutes, and we'll make sure that like any queries which you guys have, please come up with those queries, because otherwise it will become a little bit like you'll still be able to integrate the applications with SAML, but the problem would be like if in case you find some issue someday, and people are going to talk about SAML in the interview for sure. So that's why I want you guys to pay more attention to SAML and OIDC topics, because this is the stuff like which is like which is taken into account when you're giving interviews on for the Okta and all. So that's why. So make sure that you understand SAML topic very well, and if in case you guys have any doubts, we'll discuss it tomorrow. Okay. Yeah, I think Rakesh, we are good to close the call for the day. I think Rakesh is not there, but yeah, I think we are good to close, guys. Thank you for your time. Thank you.
Thank you.
Thank you, everyone. Bye bye.
Thank you.